Storage Swifters, it's Prof G, and now it's time to learn how to save images using Cloud Storage for Firebase, the service formerly known as Firebase Storage. And we've got quite a few things to accomplish, so we'll perform these steps as a two-part lesson. In the first part, we'll describe the conventions that we're going to use to save multiple images to Cloud Storage and associate them with a document associated with a restaurant or spot in the Cloud Firestore database. Then we'll use Firestore Console to set up the Cloud Storage for our app, and we'll create a new model for saving data about each photo that we'll save. And we'll write a function in our ViewModel that will allow us to save an image to Cloud Storage and create data in Cloud Firestore that will eventually allow us to find and display the data from Cloud Storage in our app. After we've done this, in the next lesson, we'll modify our app so that we can create a view to display the image we've selected and allow our user to enter a description of the image, and we'll add code to save the image when the user is ready. This should be a great way to learn how to use Cloud Firestore and Cloud Storage to work together and how to make this happen using SwiftUI. So let the big learning begin! So let me describe what's going on here when we save an image. We don't actually save images or other large files like video or audio to Cloud Firestore. Documents in Cloud Firestore really are pretty much only for text and related data like dates, bool values, those kinds of things. Larger files like images and video are stored in a special Firebase tool called Firebase Storage, or Google has actually just changed the name of this. It's now called Cloud Storage for Firebase. So if you hear Firebase Storage, it's the same thing as Cloud Storage for Firebase. And the Cloud Storage can work with the Cloud Firestore database, so our app will use both Cloud Firestore for data and Cloud Storage for images. Now it helps me to think of Cloud Storage as almost like a big Google Drive for large documents. So the image that the user picks using the photo picker will be stored here in Cloud Storage. Now how will we know where it's stored? Well, we'll create a storage reference that first points to an area, and this area is going to be almost like a folder that has the same name, so the same folder name as the spot ID, which is the name of a document that holds data on a particular spot or restaurant. So in the storage reference, this sort of folder-like area down here has the same name as the spot up here. And inside this folder that has the same name as the spot ID is where we're going to store all of the photo documents that are associated with that particular spot. And folder isn't a term that Google uses, but I like to think of this as being a folder. Now inside this folder-like area that has the same name as the spot ID, we'll give each image document a unique name using UUID. Now each image we save in Cloud Storage can also have a URL that we can use to load the image over the web. So we'll get this URL when we save the document. So once we've saved an image to Cloud Storage, then we'll head back to Cloud Firestore, the database. And in here, we'll have a photos collection that holds information about each photo, just like we have a reviews collection that has a document for each review for a particular spot. Now we'll give an image file's photo document the same unique name that we gave to the image file. And in this photo document, in a photos collection, we're going to store the image URL, that URL that we can use to load the image. Once we have this URL, we're going to be able to use it to load the image using async image. We'll do that in our next lecture. And each photo document will also keep track of a description that the user can type in for each image. So it might be something like the name of the meal they just took a photo of. We'll also store the reviewer's email address and the date the image was posted on. So this is how we're going to save an image. The image is first going to be saved to Cloud Storage, sometimes called Firebase Storage, using a reference that will act like a folder name that has the same name as a spot document. Then inside of that, it's going to act like a folder. We'll give each image a unique name. Then we'll head back to Cloud Firestore, the database, and we'll create a photo document in that spot's photos collection. We'll save the URL to access the image, plus any important data that will describe the image that was saved. So now let's do this. So if we're going to use Cloud Storage for Firebase, we need to use the console to configure Cloud Storage for our app. So open a browser, go to the console, head to your app or your project. You'll likely have only one, but I've got a bunch in here. I'm going to click on Snacktacular UI. And over here on the left-hand side, we can see that we've got shortcuts for authentication and Firestore database, since we've used both of those in this project. But now let's click on Build to see the other things that we could add to this project, and find and click on Storage. This adds a storage shortcut in the upper left, And since we haven't set up Firebase Storage or Cloud Storage for Firebase, which it's now called, let's click on the Get Started button in the center of this page. This screen looks similar to the one that we saw when we created our Firestore database for this project. So we'll start in production mode, but that means we also need to set up the rules for access. So click on the Next button. Now the Cloud Storage location here looks like it won't let me change this. This is probably because I already set a storage location when I set up the Firestore database, but this shows the East Coast location, which is what I selected earlier. I'm just going to click on Done. We'll see Firebase state that it's creating a default bucket. Now, bucket is the area for this app. I refer to that as being almost like a Google Drive, but Firebase calls the area where you save your files in storage as a bucket for the app. Now, this might take a minute to set up, and when you're done, you'll see a blank Firebase Storage console screen. There are no files in here yet, but we do need to set up the access rules. So click on the Rules tab. This isn't the same rules document that we modified when we set up the rules for the Cloud Firestore database, but the idea is the same. So we're going to change if false, which won't allow anyone to access any of these files, to if request.auth does not equal, so that's exclamation point equal, false, meaning we'll allow anyone that does have proper authentication to access any of the files. Now, it is possible to offer even more security in here, but since all of the images that are posted are supposed to be posted for public access, if a single user is authenticated, they should be able to see all of the images. Then we'll click on the Publish button, and you've now got Cloud Storage for Firebase set up for this app. And this is the set of procedures that you'll follow if you ever create a new Firebase project that uses Cloud Storage. And I'll click back on the Files tab, and this is where we'll see any files we save to Cloud Storage. So to begin saving data on each photo, we're going to add a new model file that will contain a struct that we'll call photo that will hold the data for each photo that we want to add to a spot. So I'll right-click on Place, select New File. This will be a Swift file, not a SwiftUI view, and we'll call this photo with a capital P. And the setup of this file will be similar to all the other model files that we've created that worked with Cloud Firestore. So we first need to import Firebase and import Firebase Firestore Swift. Then we'll say struct capital P photo, colon, and this is identifiable, comma, and codable, open and close parens. And our first property uses the @document_ID property wrapper, followed by var ID colon string question mark, just like all of the other models we created to save data in Cloud Firestore. Next, we'll say var image URL string equals empty string, and this will hold the URL for loading the image. So each file we save in Firebase Storage can have a URL associated with it that we can use to load an image over the web. So when we save an image as a file to Firebase Storage, we'll also retrieve that URL associated with that particular image, and we'll save it to the photo document in the photos collection that's inside the document of a given spot. Now, we don't store the actual image in Cloud Firestore. We're going to store the image in Firebase Storage, but the URL that we save here as image URL string is going to allow us to access that, and we'll be able to load it in using async image. Then below this, we'll say var description equals empty string. That'll simply describe the image. So for example, the user can enter a description of a menu item that they've taken a photo of. Then we'll create var reviewer equals, and here we'll get the current user as the person posting the photo, which should always be the case. You'd never post a photo under somebody else's user ID. So we've done this before. This is just going to be equal to capital A auth dot lowercase auth with open and close parens dot current user dot email, and this is optional, so we need to add double question marks afterward and an empty string. So if the user's email came back as nil, which it never should, we put an empty string in here. Then var posted on equals, and we'll pass in a capital D date with open and close parens. Then down below, we're going to create a dictionary computed property, as we've always done, and this will create a dictionary with the data formatted in the format that Cloud Firestore requires when we save a photo document. So we're going to say var dictionary colon, and in between brackets, string colon any. That's the type that we're going to save. It's a key value pair. And then open and close curlies, and in between the curlies, we return open and close square brackets. And in between the brackets, we're going to pass in the key value pairs for the dictionary Cloud Firestore will save. So this is going to be the string, image URL string, the same name as the variable that we have up here, colon, image URL string, comma, the string description, colon, description, comma, the string reviewer, colon, reviewer, comma, and the string posted on, colon, but remember, we need to convert Apple's data type into something generic that Cloud Firestore can store. We can't save Apple's custom date type that Apple uses to store dates and times, but we can perform the conversion with timestamp, selecting the option with date, and we'll pass in capital D date, open and close parens, and this will just convert the current date and time into a standard time that Cloud Firestore can store. Now let's create a function to save an image, and we'll do that in the spot view model. So we'll add this just above the closing curly in the class. We'll say func save image, and in between parens, we'll pass in a spot colon of type capital S spot, comma, and we'll also pass in a photo colon of capital P photo, comma, and we'll also pass in a value called image colon of type UI image. And that's the name of the data type. The first three letters are capitals UI and I. And after the closing paren, this will be an async function. Also enter an arrow, and we're going to return a bool value, which will indicate whether or not we were able to successfully save the image. And after this, we'll put in open and close curlies. And we'll see Xcode will say, hey, if we want to use the type UI image, then we need to import UI kit. So we can click on the error circle and click import UI kit, but there's more we need to import. So we can scroll to the top of the file. We also need to import Firebase Storage. And now we're ready to finish the function. So the first thing we'll do is make sure that our spot ID is not nil, because we need a valid spot ID to save an image and a photo document. So we'll say guard let spot ID equals spot.id, else open and close curlies. And if we fail the guard case, inside the curlies we'll return, passing back false. And also above the return statement, I'll also print angry emoji, error spot.id double equals nil. Now below the guard statement, if we can continue, then the next thing we'll do is create a unique name for the file that will contain the image we're about to save to cloud storage. So we'll do this with let photo name equals UUID, open and close parens, .uuid string. Again, this will be the name of the image file. And then below this, we'll set up an instance that allows us to access cloud storage with let storage equals capital S storage dot lowercase storage, open and close parens. So this creates a Firebase storage instance in the same way we use the constant db when creating a Firebase Firestore instance. And then we'll set up the reference we'll use to save our image file, and we'll do that with let storage ref equals storage.reference. This has two parens after it. And then we say dot child with this path option in here. And the path wants a string. And this is simply going to be the directory where we're going to save the file with the file name in here. So the path we'll pass in is going to be a string between double quotes, stringinterp / stringinterp .jpeg. Now the first string interp will be the spot ID, which remember is the name of the folder that will hold all of the images that are related to that spot, and the folder or directory has the same name as a spot document, which is spot ID, and then after the slash, the second string interp should say photo name, and that's the value we created with UUID above. So this is the location and name of the file that we're about to save that will include our image. Now next, since we're saving data for display on the web, we actually don't need it to be a full image size. Remember, iOS devices take very high resolution photos, so it's a good idea to compress the image. That'll save us on storage and on transfer time when we transfer the image back and forth. So we can compress the image by saying guard let resized image equals image. This has a lowercase I. Remember, that's the name of the image that we pass into our function. It's of type UI image. And then here we'll use a method after it, .jpeg data. Now this accepts a number that indicates the compression quality. Press return to accept this. We'll pass in 0.2. I believe that's going to create an image that's about 20% of its original size. And you should see even after doing this that the images will look great in our app. Else open and close curlies, and we'll print an error, could not resize image, return false. I can see now that I have the word print repeated twice in here. I'll fix that in a moment. Then below this, we're going to create something called metadata. Now, metadata is just data about data, or data that describes data. Now, we actually don't need to include metadata in here, but by setting up metadata here, we're going to describe the type of file that we're going to save. That's going to be a JPEG file, and this is going to allow us to render the file as a JPEG image when we click on the file in the Firebase console using a browser. So we'll just say let metadata equals storage metadata. This includes the open and close parens. We don't need to pass anything in here, but on the next line, we'll modify the metadata value we just created with metadata dot content type, setting this equal to the string image / JPG, all lowercase. And again, setting metadata like this will simply allow the file that we're about to save to be treated like a JPEG value when we view it in the browser, and we'll see the graphic image when we click on the file. Now, even though we call this a JPEG with JPG, this will also show the file graphically in a browser, even if it's a PNG file. Then we'll create a variable to hold the image URL string, setting this equal to an empty string first. So we're going to create it here because we're about to enter a closure and we want to modify this value in the closure, but we want to have access to it outside the closure once we update the value. So we'll declare and initialize this with var image URL string equals empty string. And now we're ready to actually save our image, and we do this inside of a do catch clause with do open and close curlies, catch open and close curlies. And in the do clause, this is where we'll use our storage ref to save our image to cloud storage. And this is an async method too, so we set it up like this. Let underscore, we don't need the result, equals try await storage ref dot put async, and select the option with upload data and metadata. And now the upload data we'll pass in will just be the resized image. We can pass in the result after compressing the JPEG. This is going to be fine. And the metadata is just metadata, the value we created above. And oh yeah, let me fix this double print statement error up here. And I'll copy this and I'll paste it into the catch area down below, changing the error to read error uploading image to Firebase Storage, followed by return false. Now, if this does work out, in the do clause, I'll print a confirmation method with camera flash emoji, image saved. And below this, if we save the image, I want to get the URL that I can use to read this image, and we'll use this with async image to display the image in our app in a future lesson. Now, this also uses a method that could throw an error, so we need to include yet another do catch clause nested inside the do clause. So we'll say do open and close curlies, catch open and close curlies, and in the do clause we'll say let image URL equals try await storage ref dot download URL. This has empty parens after it, so this will get the URL that we can use to access the image we just saved at this storage ref. And remember, this is going to be of type URL, which is a special Apple data type. We need to convert this to a string so we can save it to Cloud Firestore. So we'll say image URL string equals the string, in between double quotes, string interp, and inside we'll pass in image URL. And I'll put in a comment that says, we'll save this to Cloud Firestore as part of a document in the photos collection below. And I don't put in a return statement in the do clause here because if this works, then we need to save data to Cloud Firestore too. But if this fails, then we'll add an error statement in the catch stating error could not get image URL after saving image string interp error.localized description. And if we're in the catch, we'll also return false. But if both of these do clauses work out, then we'll continue just before the closing curly in the function. And now we need to save a document to the photos collection in the document named spot ID. So to save with Cloud Firestore, we first need to set up a Firestore instance with let db equals capital F Firestore dot lowercase Firestore with parens. We've done this before. And then we'll set up a collection string that points to the location where we want to save our photo document. So we'll set this up as let collection string equals, and the string in between double quotes, spots slash string interp slash photos. And in the string interp, we're going to pass in spot ID because we're about to save in a photos collection for a given spot ID. That's the document that refers to the restaurant or the spot that this photo is associated with. And then we'll save our data in a do catch clause. In the do, we'll first modify our photo variable to include the image URL we just got after saving the image. So we'll do this by saying var new photo equals photo. Why don't we use photo? Remember, the photo that we pass into this function is a constant, so we can't change its image URL string property. So what we need to do is we need to create a new variable in here. We're going to call that new photo. We'll say that equals the photo constant that we pass in. And then below this, we'll just say new photo dot image URL string equals image URL string. And now we'll save this with try await db.collection, passing in the collection string that we created above, and we'll follow this with .document, selecting the option with the document path, which is the string of the name that we're going to use for the photo document, and we're going to use the same name that we used when we saved the image to cloud storage. That's photo name, that name that we created with UUID, and then after this we'll say .setData, passing in document data as a string any dictionary. What do we pass in here? You guessed it, new photo.dictionary. And if this works, we'll print out cool emoji, data updated successfully, and now we can return true because we have saved our image, we've got our URL, and we've saved our photo document. Otherwise, in this last catch clause, we'll print error could not update data in reviews for spot ID string interp, passing in spot ID. Although now that I look at this, I should have written could not update data in photos for spot ID, since we're saving this to the photos collection, not the reviews collection. Sorry about that. This is just a print message that'll show up if you get an error in here, but you should change reviews in here to photos, and we'll return false if we're in the catch clause. So to recap, we create a unique photo name, we create a storage instance, we create a storage reference that points to a folder or directory that's named spot ID, and that'll save a file with the UUID that we just created. We resize the image, we create metadata, and we specify that this is going to be a JPEG image. This will just allow us to display the image in Cloud Storage in our browser when we look at it in the console. Then we create an empty image URL string, but we'll modify this if we're successful. We'll save the data to Cloud Storage with this line here that uses storage refs put async image method. We pass in our resized image and the metadata we created above. If this works, we get the URL that will allow us to access the data that we just saved. And we'll be sure to update our photos image URL string with this value. If all this works, then we need to save a photo document to the photos collection of the spots document. So down here, we create a Firestore database instance. We set up the location for saving the photo document as a collection string. Then we need to create a copy of the photo struct that we pass in because this is a constant. We'll modify the image URL property of the new photo, passing in our image URL, which is the URL that will allow us to display the Cloud Storage image. Then we use setData to save the data on a photo document with the same photo name that we used when we saved our image to Cloud Storage. And one more thing to note, when we previously saved a new document to Cloud Firestore, we used the add document method and we let Firestore create the document's name, but we're not doing that here. We already have a document name. Remember, we're using the same name that we used when we saved our document to Cloud Storage, and that's the name we created with UUID. So since we have a name, we can just use setData here. We don't need add document. If we don't have a document, setData will create a document using the name that we pass in. If that document exists, it'll replace the document with whatever data that we pass in. So those are all the steps we'll use when saving a document in Cloud Storage and associating this with a document in Cloud Firestore. Now let's modify our app so we can use the function we just wrote. That's what we'll do in part 2, which is coming up next. Stay tuned for more big learning.